Okay, so here is a tutorial on how to tackle an equilibrium problem. All right, and so what we've got here is we've got a sign held up by two ropes with a tension of 150 newtons in each rope. The angle between the ropes is 100 degrees. What is the mass of the sign? So, real quick, I'm just going to draw in that this is 100 degrees right there. Now, um, that can help us out a couple of different ways. I realize that this isn't the best little sketch here, but if you kind of take a look at this, the sign is flat. That means that makes a straight line. That means that this x and this x plus that 100 degrees has to equal 180 degrees. Because this is symmetrical, or it should be symmetrical, that means each x should be the same. So that means there's 80 degrees between them. So that means each angle here is about 40 degrees. All right. Now, if we come over and we draw a free body diagram like this, all right, we got our sign. Right now we have our force of gravity acting down, and then we've got the two tensions, and I'll call the one on the left tension 1, I'll call the one on the right tension 2. So we got T1 and T2 acting on the sign. The problem is this is not very useful to us. The reason it's not useful is we've got these two tensions here going off on angles. So what I need to do is I need to calculate a component for each one. All right. And if I do that, and I redraw my free body diagram again to a second time, so I have my sign and my force of gravity. Then what I'll have, I'm going to redraw it with this component. So this would be T2 in the x direction. This would be T1 in the x direction. And then I would have two components going up. I'd have T1 in the y, and I'd have T2 in the y. So each tension there would have a y component. Now, what's nice about this is because it's at equilibrium, I know that this is true. I know that the force of gravity is going to be equal to T2y plus T1y. Now, what makes this really nice, because it's symmetrical, right, is T1y is going to be equal to T2y, because they're each going to pull equally hard. If the angles are the same, they have the same forces. So really all I need to do is find one of them, and then I can pretty much have my answer. So let's work through this and see if we can figure out how to calculate this. So if I'm just going to take T2 for right now. Remember, and we'll draw in our components. If you remember, that angle there has to be 40 degrees. And go up and look at our diagram there. That's how we get that to be 40 degrees. And so all I need to do is this would be T2x and T2y. So what I'm really going to do here is I'm just going to find T2y. Now that would be sine of 40 is going to be equal to T2y over T2. Now, when I go to solve for that, all I need to do is multiply both sides by T2. That cancels, multiply by T2. And so what I'll end up with is T2y is equal to T2 sine 40, or 150 sine 40. When I punch that in, T2y, so if I punch that into a calculator, I get 50 times the sine, oops, I get 96.4. So I get 96.4 newtons. Now, if I go back up here, all right, I know that T2y is 96.4. I also know that T1y is 96.4. So that means my force of gravity is going to end up being 192.8. And you know what? We'll just probably round that to 193. But once I know that, now all I have to do is use, I know that this is 193 newtons. Now to find the mass, this is a piece of cake. We know that Fg is equal to mg. And so then it's 193 is equal to the mass times 9.8. And so the mass is equal to 19.7, 19.7 kilograms. All right. So to recap, really what we need to do here is you take your initial sketch, you draw it into a free body diagram, one that's useful with components. Then we find those components, figure out what those components are, look and see what the components add up to, how do they equal Fg, and then just Fg equals mg, and we can calculate what it is. And again, here, let me clean this up a little bit. This is supposed to be 19.7. There you go.